Hi everyone, and welcome to this Cloud Academy webinar. I am Alex Casalboni, and today we are going to discuss what function as a service means and how you can apply this new model, programming and delivering model, to your own company and your own infrastructure. So first of all, let me introduce myself. I'm Alex. I have a computer science background, and I've been working in software and web development for the last few years. I've joined Cloud Academy more than 3 years ago, and now we are helping thousands of students learn cloud computing, learn AWS, Azure, and other cloud computing technologies. So what are we going to talk about today? First of all, we want to explore what function as a service means. And this is not a trivial point because it's a bit confusing. What is function as a service? What is serverless? How do they correlate to each other? And then we will see what the open source world can offer as far as function as a service. So what kind of platforms and frameworks are out there ready to use for you. And then we will see finally what alternatives and options are available to build your own function as a service platform on Kubernetes. So I think it's an interesting point because many of you already have a Kubernetes cluster, and maybe you want to run your own particular use cases on your Kubernetes application. And then we'll see why would you ever choose to build your own function as a service. Here I call it on-premises because, as opposed to using an official cloud platform like AWS, Lambda, or Microsoft Azure Functions, or Google Cloud Functions, or Iron.io, or any other platform that already offers function as a service ready to use. Just a quick note about what we will not cover in this webinar. So we do not have time to cover all the details about Kubernetes and all the details about the programming model, but I recommend you our latest webinars that you can find on cloudacademy.com/webinars. By Adam Hawkins, and they are amazing, very hands-on, and you will learn a lot about Kubernetes and Docker and other technologies. So today we want to focus on function as a service. Let's get started. So what does it mean? What is function as a service? So it was introduced by AWS Lambda, as you may know. And it was born together with serverless. So for a while, we thought that serverless and function as a service was the same thing. I think now it's a bit clearer that function as a service is one of the components of serverless, or at least one of the phases of serverless, one of the things you need to be serverless, which is a computing model where you execute and deliver and focus on functions instead of applications or virtual machines or operating systems. So it is the core component of serverless that allows you, first of all, to not manage any infrastructure directly. Of course, your function runs on a server. Somebody has to provision that server, but that person, that responsibility is not yours, at least if you use a ready-to-use platform like Lambda or Google Functions. As we will see today, if you build your own function as a service, of course, you are also responsible for the infrastructure. But the main thing here is that as a developer, your unit of delivery and your focus is on individual functions instead of applications and databases and containers and virtual machines. So this is totally aligned with the microservices approach, and we will see in the next slide what this means. So I think function as a service also comes with a few benefits, or at least let's say, requirements as well. I think it should allow you to go multi-language in the sense that you must be able to bring your own code. So if you want to use Python, use Python. You can use JavaScript, you can use Node. If you like Java or Scala or Go or any other language, I think a real function as a service platform should allow you to use the language you prefer, or to have a multi-language application where every function is implemented in a different programming language. And then another interesting point is that it should be highly scalable in a transparent way, both as far as the load that you need to sustain with your application, and also as far as pricing. Usually, you have a pay-as-you-go model where you are charged based on how long your functions run, instead of how long the container is up and running, which you don't care. Basically, you don't have idle, you don't pay for idle. But again, this is if you use a function as a service platform, while if you implement your own, as we will see later, also this scaling and pricing transparency is not really there, because you are also responsible for the infrastructure. So if you're interested, there is also a Wikipedia page. So this is getting real, So how do you do it? How do you approach function as a service? What does it mean to actually use it on a daily basis? So as I mentioned already, it means focusing on functions. You can think of functions and microservices. So yeah, we are not reinventing the wheel. Microservices have been up there for a while. That kind of culture and approach is really powerful. What changes here is, as we said already, the unit of delivery. So as a developer, you want to focus on function and not all the infrastructure around it, all the processes and operations and the workflow that you need to put in place to deploy your microservice. So what are all the other requirements for function as a service? Well, if you want to do it right, I would say you need to have a way to manage different versions of your functions, and eventually different stages of your functions. Imagine you have a dev and a prod stage, so you can test, or you can have a local environment. So executing locally is useful, but you also need to test the whole workflow. So staging is a really useful feature. And then you need to have all those tooling and processes that allow you to have cross-team collaboration and allow you to automate all the development and deployment workflow. So we already talked about some of this tooling. If you're using Lambda or OpenWhisk or Azure Functions, you already have some tools like the serverless framework or other micro frameworks that help you deal with this collaboration and automation side of function as a service. And then all the other interesting topics, like how do you invoke your functions, how do you trigger them, what events are available. So this is very interesting, and every platform has a different approach to this, almost every platform. And how do you do local unit testing? How do you do integration tests with the with the workflow? And how do you do continuous delivery and continuous integration? So all these points, if you already have, let's say, a microservice architecture, they're not new to your workflow. If you go for function as a service, let's say in some platforms, all these topics are still very new, and sometimes they might be unstable in a way, but they are getting simpler every week. So new services are announced, and new tools help you deal with all the best practices and the little problems you may encounter. So these are all important points that you need to take into consideration whenever you use function as a service. And if you are a developer, I think you can see the value of focusing on functions and being language independent in your workflow and helping your team develop in the language they prefer and having a stable versioning and testing environment. So this is really powerful. So let's see what is out there in the open source world. Of course, there are many tools in the public cloud world, like AWS Lambda and Azure Functions, and Google Cloud Functions is still in preview, but there are many available tools. Some of them are open source. So let's see what's available. Here I want to talk about 3 of them. There are not really many so far, but here I think I wanted to find the 3 most interesting ones. So the first one is Apache OpenWhisk. It was initially developed by IBM, but recently it's been integrated into the Apache community, and now, I mean, it was already open source, but now the community is growing much faster. And then on the right, I included Iron Functions. So it's an open framework, and it supports different ways of delivering and deploying. It supports Kubernetes, it supports Docker and other deployment strategies. And it is part of Iron.io, which is one of the many competitors of Lambda and also OpenWhisk and others. But the whole framework is completely open source. So you can check it, you can help the community grow, and you can install it yourself in your infrastructure and try it out. And then I also included a third example of open source function as a service in the wild, which is Funker. So Funker, I think, is supposed to be like functions and Docker, kind of a mixed word. So I will tell you about it. So I already mentioned what is OpenWhisk. So IBM was involved. Now it's totally open source. It is still the function as a service component of the IBM cloud, Bluemix. So I didn't want to talk too much about OpenWhisk today because it does not support Kubernetes yet. There is an open issue on OpenWhisk where people started asking about this Kubernetes support, and the community is willing to work on it, I think, but it's still an open issue. So if you want to monitor the situation, please check this link. And if you're more curious about Apache OpenWhisk, I mean, what are the features and how to use the public IBM Bluemix OpenWhisk, you can check this link here on the bottom where I published my personal overview and review about the service and what allows you to do. And now that it's part of Apache, it will be growing much faster than before. This review is already a few months old, I think November, but please give it a read and let me know what you think. I think it's very promising, and now if it grows fast enough, it will be very interesting in a few months. I think 2017 will be a very interesting year if you are into serverless and function as a service. So let's see, Funker. So Funker, let's say it was, I think, kind of like a personal project. It is based on Docker Swarm, not Kubernetes, but I want to mention it because it already has support for Node, for Python, and for Go. So it's a very interesting project. Let's give it a try. So as you can see, this is a general repository where you have the abstract generic documentation, and then you have three different client implementation, not really client, three different implementation for each programming language. So basically you can define functions in Go, in Node, or in Python, and then it will take care of provisioning Docker containers for each one of your functions and allow you to deploy them in your swarm. So it's a very interesting project. It's not really huge or famous, but if you're curious to give it a try and if you already have your swarm, I think it's worth mentioning. Let's keep going. I already mentioned iron functions. It is interesting, I think, because it can already run on Docker and on Kubernetes. So it's an open platform. You can check the website here. And it is the open source serverless computing. And I think it's like framework. And it supports many features. And I haven't used it personally, but it supports both Docker and Kubernetes. And if you want to give it a try, I think it's a good candidate. So let us know what you think and if you have already used it. So let's go on and see what can you actually do on Kubernetes. So what you have seen so far, only iron functions can run on Kubernetes. OpenWhisk will do at some point, eventually. Funker is not meant to be working on Kubernetes. So what do we have for Kubernetes? I identified three different, let's say, frameworks. The first one is more of a proof of concept, but I identified these three, so kubeless, function, and fission, or fission, I'm not sure. So kubeless there's no logo, so I think it was meant to be just a proof of concept, as they mentioned on the public repo. And it is totally written in Go. All of these three frameworks are written in Go. And it supports both HTTP triggers and publisher-subscriber triggers. So you can publish messages on a topic and they will be given to your functions. And it is, of course, open source, and it is based on Apache projects such as Zookeeper and Kafka for configuration management and PubSub. So what can you do with kubeless? It is a proof of concept, but they managed with a very simple interface. So you define your functions. I think it supports both Python and JavaScript. So you can define your runtime when you create a function. You specify the file and the handler as you would do for Lambda, for example. And then you can specify the HTTP trigger. And kubeless will manage, they will provision a container on your Kubernetes cluster, and it will run your function. It will give you a context object with a JSON, which would be your event data in the Lambda or Google function or Azure context. So I think it's pretty simple. They managed to do a lot of tooling. I think the abstraction level is pretty high, and the approach is very, very similar to what you would do with Lambda or OpenWhisk or Iron functions or Google Cloud functions. Of course, many things are missing, and we will see later what is the current pros and cons of implementing your own function as a service solution. For example, you cannot run many other languages, and you don't have a lot of triggers that you may want to, that you need to develop yourself in your Kubernetes environment. So let's go on. What about function, the second framework that we identified. So I think this is the oldest. I couldn't find out if function or fission is older, but I think function is the oldest, and it is backed by Fabric 8, which is backed by Red Hat, and also this one is written in Go. And so one of the pros of this framework is that it's already integrated with the Fabric 8's developer platform, which could be both either a pro or a cons. It really depends. Some people think it's too tightly integrated with Fabric 8, but I think it's still a powerful framework, although only Python is supported, but it's based on many other Apache projects, and it already supports more than 200 components. Just to make a few examples, there is already a Twitter connector, a Facebook connector for Git, for MQTT, for WebSockets. What else? SQL, MongoDB, or there's a timer connector that allows you to schedule functions on a set of interval. And there's one for Kafka. There are many for other AWS services if you want to interact with AWS. So I think it's a powerful framework, and the abstraction level is almost the same. So for the developer, you just write a function. You just define your exports, and you have a context and a callback, very similar to what you would do with Lambda. And then you just call your callback with the exit status and the body of your response. So you just install the framework, and you can create functions just giving the file. Everything will be inferred by the file name and by the function definition. And then you can create flows. So based on which connector you want to use, you can define different flows. Here, for example, we are creating a flow between a timer every 5 seconds, I think, and the function that we just created, which is available as HTTP hello. So for the developer, the abstraction is still very, very similar. And then we go on, and what about fission? So I think this is the newest, and I think it came out in January or just a few weeks ago. And I think this was slightly different. So it's backed, who's backing this? Platform 9, I think. And it's also written in Go, and it was designed to be as extensible and fast as possible. I guess they could understand what was missing in the other frameworks and try to fix those problems. For example, one of the many problems that almost every function of the service platform has is the cold start issue. So what happens is, if you don't call your function too often, it will probably, the platform will probably take those containers down, and the next time you call your function, the platform will need to provision a new container, bring your code into the container, and warm it up, basically. So Fission decided to keep a warm pool of containers ready to serve your functions always, even if you don't call them. So, of course, the cost implication here, you need to be aware of this. Maybe it's not cheap, but I guess they just said, why should we have this cold start issue? It just doesn't make sense. For example, even in Lambda or Azure Functions or Google Functions, I will be happy to pay a little bit more just to keep my functions warm. So that's what they implemented. That's what they had in mind while developing Fission. So it supports only HTTP triggers for now, but it is completely extensible, and the community is working on new triggers. I can imagine, again, timer, pub sub, like topic messages, or like database events or object storage events, stuff like that. Same for languages. So for now, it supports only Node.js and Python, but it is fully extensible. So you're free to contribute to the project and implement the support for new languages like Java or Go or whatever. I'm surprised that it is written in Go and it doesn't support Go, and I would guess that would be the next language to support, for coherence. Again, it is very similar. Actually, the function here is completely identical to the previous framework, the function framework. The console, the terminal tool is a little bit different. You can create you have to create an environment first, and then you have to define your function. You have to explicitly give it a name, specify the environment, and say and specify where the code is, in which file, and then you can create a route. Only HTTP is supported again, so creating a route totally makes sense. You specify the method and where what the URL would be and which function is connected to that URL. So this is more similar to kind of a API gateway approach, if you are familiar with AWS, where you have functions and routes, function and API gateway. Again, the programming model for the developer is almost identical. So if you have the same function, you can easily bring them across different frameworks. And you just need to update your deployment scripts or your automation side, not your development side. I think this is very powerful at some level, of course. So why would you ever use on-premises functional service? So imagine you have a Docker swarm or a Kubernetes cluster. Why would you ever decide to manage your own functional service platform? So I identified a few pros that you may want to consider. For example, this is not really about Kubernetes only, but the abstraction layer for developers is really powerful, I think. The approach is almost the same in every framework, in every container orchestration platform whatsoever. So the ability to abstract most of the details for the developers is really powerful. And the ability to bring your functions back and forth, different frameworks and different functional service platforms is really interesting. And then, of course, it's open source. So if you have a problem, you can fork it. If you have an idea, you can open a pull request. You can contribute to the community. You can discuss. You can fix things before they happen, before they break your stuff. You can choose when to upgrade if you want to upgrade. That's all. These are all things you can't do with a public cloud provider like Amazon or even Google or Azure. If you have your own, you have more control, not only on the code and the platform itself, but also on over the infrastructure. Of course, this is a pros if you know what you're doing. So if you have a DevOps team, if you have an operations team that is already managing a cluster or a Kubernetes cluster, whatever. Of course, this allows you to have more control, which also means that you have fewer non-functional limitation. Imagine you really have to run your functions for 30 minutes. So by far, there is no public cloud provider that allows you to execute your functions for that long. Even if you use Lambda, and now you can use step functions to orchestrate your functions and eventually have a long-running task, you are still constrained by the pricing and functional and non-functional decisions of that cloud provider. So if you have your own and you control the infrastructure and you decide my functions can run forever and ever, or my function can have as much RAM as they need, or my function can do whatever I want, basically. So you have the full control over your function as a service. This is a big pros, I think. So on the other side, all this better control and fewer limitation means that at some level it might be cheaper, and at some level it might be even faster. If you think that in this cluster that you are managing, only your functions will run. So that means you're not competing for resources. If you have enough load and enough functions and enough people using this cluster and this approach, it means overall it will be easier for us to estimate costs and probably also to distribute your load on your containers and costs. So the overall solution might be cheaper with respect to using a public cloud provider at the cost of spending more on infrastructure management, of course. And what about, the other side? What about the cons? Why it might be problematic at some levels? So first of all, I identified two big categories. First of all, there are many things missing. Many features are missing in these open source frameworks and function as a service platforms. They are open, but they are, I would say, at least 1 or 2 years in the past, behind. So you don't have many of the things we talked initially, all those versioning, staging, environment variables, custom timeouts, or testing, monitoring, logging capabilities, and all those very nice permission and authentication that you have, for example, with Amazon IAM. You don't have all the orchestration functionality. For example, if you want to use step functions to do retry policies or to do long-running tasks with human interaction. Those are a lot of features, not to mention all the native triggers of your cloud platform. So if you are on Google or Azure or Amazon, you have all those native triggers from your cloud storage, from your cloud database, from your cloud streaming queues, and I think this is very useful if you want to use function as a service as a serverless component. So you want to build serverless applications. So you don't want to you want to react to events. You want to have as many events as possible. That's what AWS is doing. Almost everything in AWS can be event-driven, and you can bind your Lambda function to almost every other service. S3, DynamoDB, or Cognito, or Kinesis. That's very powerful. The other cons I identified, and I already mentioned it many times already, is that you'll be responsible. You will be the owner of everything. That's good. I also mentioned this in the pros because if you know what you're doing, if you're a DevOps, if you already have a cluster up and running for your, your web application whatsoever, having control and responsibility and ownership is a good thing. But it also means that you have to deal with all the provisioning and configuration, and you have to make sure there is very high uptime, you have to monitor everything. All this operational complexity will be on you, on your team. So you have to find, you have to decide if they might be cheaper and might be faster, benefits are worth this effort. And I personally believe that if the serverless movement is trying to empower developers and to remove all this operational complexity from the daily workflow of developers, I think this is a very tough choice. So in a near future, when all these frameworks are more mature and you have a lot of features and all the provisioning and operational complexity is much easier than it is now, this might be worth trying. So I think it's as everything else, a trade-off between pros and cons. So let us know what you think, and if you think the pros are worth. I think in many scenarios they will be enough to give it a try. Maybe start with non-critical functions and see what are the limitations, and if they are too much, you can always do a kind of a hybrid approach. So here I want to bring a few more additional resources. If you want to know more about Kubernetes or Docker or other orchestration-oriented technologies, we have had 3 or 4 fantastic webinars by Adam Alkins, and we will have more, I think, next month. So you can visit cloudacademy.com/webinars, and we have more than, I think, 30 or 40 free webinars that you can attend. And please feel free, even right now, to ask questions. I will try to answer a few if we have enough time, and I will report all your questions and answers on our blog in a few days. So thank you for attending. I hope you learned something new today, and let's see if we have time for a question or two. Okay, we have a question. So what's the relationship between functions and APIs? I guess we would want publicly facing APIs that forward to internal functions. Yeah, that is true. So in the general function as a service model, you have functions that is basically your code, which have input-output programming model, very simple, intuitive for everyone. And usually you combine these functions to public APIs, or you can instruct your platform to invoke your functions whenever something happens in the environment, like a new file was uploaded, or there is a new stream ready to be processed, or there is a new record in your database, stuff like that. So it's not always an API. It might be just a little function to execute whenever some specific event happens. So another question, which other function as a service exist aside AWS Lambda? So Lambda was the first one, so I would say it's more mature and feature complete. Other alternatives are Azure Functions, if you are familiar with Microsoft Azure, and also I mentioned OpenWhisk today. You can try it out on IBM Bluemix. It's the public cloud by IBM. Or, for example, Google Cloud Functions. I think it's still in alpha, not even beta. So you would have to wait and or apply for the alpha version. I can think of a few others like Iron.io, or Webtask, or I think I found a new one recently, like Unit Cluster. There are a few others. I think the power or the the main benefits of these functions as a service is how much they integrate with the corresponding platform. So that's really up to you. Let's see if we have any other question. Okay, we have a couple more. So are you seeing a rise in the industry trend, moving more from platform as a service towards function as a service? I would say yes. I think this is happening. It's really new and it's not understood by everyone. It's not everyone likes it. And not everyone accepts it. Some people are still complaining that serverless doesn't make sense. There must be a server somewhere, of course. But I can see this movement. Simply, I think it started from the bottom, from the developers, because it's really about developers' empowerment, about being independent, about having a programming model and a delivery model that's trying to remove all the operational complexity from the development workflow, and that's really powerful because then also companies understand that you can move faster. Cheaper is not always the case. Sometimes it is, but that's really depending on the use case. Okay, I'm afraid we are out of time. I see new questions are coming. Thank you for asking. I'll make sure all these questions are posted on our blog and our community. So if you have any specific doubt, please reach out to me on Twitter or at alex@cloudacademy.com. And you can write on the community. It's cloudacademy.com/community. So thank you again for attending this webinar, and I really hope you learned something new today. Thank you. Bye-bye.